I welcome you to the class. Yesterday we were trying to solve the question problem 20.1. Okay. In the problem 20.1, what we have a disk which we are representing by capital D, and we have a platform which we are representing by the capital P. Okay. So as far as the disk and the platform are concerned, the disk and the platform that we have in hand, we are given that the angular velocity of the disk is given to us. The angular velocity of the disk with respect to the platform is given to us, and its magnitude is 3 radians per second. And if you curl your fingers in the direction of this arrow, the thumb will be along y direction, so it is 3j cap. And the angular velocity of the platform with respect to the ground is given to us. Angular velocity of the platform with respect to the ground is also given to us, and for us that is equal to 1. Its magnitude is 1, and if you curl your fingers, the thumb will be along negative z direction, so it is minus k cap. Okay, so this is. Now the question is, I want to make you understand here the notations, or not the notation, I should say, the assumptions that the author has taken while making this, while giving you the numerical data about the problems. For example, the author says that the disk is spinning, that this disk is spinning with a constant angular velocity of 3 radians per second. Look, this disk is on the platform. Okay, so this is the angular velocity of the disk with respect to the platform. Okay, then it says that the platform is rotating with angular velocity of 1 radian per second. That is angular velocity of the platform with respect to the ground. Okay, this is the sense that you have to follow in all the questions of this book. Okay, so what we have, what we are given, this things we are given. So first and foremost, what I am calculating in order to calculate the angular acceleration of the disk. Okay, because it says what is the angular acceleration of the disk. Look, if you look at the values of the disk, the angular velocity of the disk with respect to the platform is how much? 3 j cap. Okay, if you differentiate angular velocity of the disk with respect, even it says that it has a constant angular velocity. Okay, when angular velocity is constant, therefore angular acceleration of the disk with respect to the platform will be equal 0. But what it says, the question is determine the angular acceleration of the disk. That is, we have to find the angular acceleration of the disk with respect to the ground. We have to calculate it. Okay, and what we have to calculate, and the velocity and acceleration of point A. We have to calculate velocity of point A with respect to the ground, and acceleration of point A, linear acceleration of point A with respect to the ground. These things we have to calculate. Now first of all, we will use this angular acceleration of disk with respect to the ground. Before you calculate the angular acceleration of disk with respect to the ground, we should be knowing the value of angular velocity of the disk with respect to the ground. Okay, and we know angular velocity of disk with respect to the ground is equal to angular velocity of the disk with respect to the platform plus angular velocity of the platform with respect to the ground. This is by making use of the property of this additive property of addition property of angular velocity. Okay, that will be equal. Look, angular velocity of disk with respect to platform is how much? 3j cap. So I will write this as, this is 3j cap, and angular velocity of platform with respect to ground is equal minus k cap. So it is 3j minus k cap. Okay, I will call this as, this is angular velocity of disk. This is the value of angular velocity of disk with respect to the ground is equal to this. Okay, so I will call this as equation 1. Okay, now let me calculate the value of angular acceleration of the disk with respect to the ground. How do we calculate the value of angular acceleration of the disk with respect to the ground? So the last expression that we had, the expression when we were talking about the angular acceleration vector, at that time we had the expression for angular acceleration. We had, it was, we had derived something, angular acceleration of c with respect to ground is equal to angular acceleration of, is equal to angular acceleration of c with respect to beta plus angular acceleration of beta with respect to ground plus the gyroscopic terms, that was angular velocity of b or beta with respect to ground, and its cross product with angular velocity of c with respect to b, okay, or beta. So this is the expression for angular acceleration vector, which we have already derived. Okay, now what we have in place of c, we have to calculate angular velocity or angular acceleration of disk with respect to ground. So we'll write our expression will be, therefore we will be having in place of c, we'll write disk angular acceleration of disk with respect to ground, okay, is equal to angular acceleration of c is disk, angular acceleration of disk with respect to the another frame of reference, which is our platform frame of reference. Okay, we have two frames of reference, platform and the ground frame of reference. Okay, so we have angular velocity of c with respect to ground. C was the object, the rigid body. Okay, the angular acceleration of c with respect to the ground, c in place, in our place, c is disk. Angular acceleration of disk with respect to ground is equal angular acceleration of disk with respect to platform, that is angular acceleration of disk with respect to platform, plus angular acceleration of b, our b is platform, that is angular acceleration of platform with respect to the ground, plus the cross product between angular velocity of this, that is angular velocity of platform with respect to ground, and its cross product with angular velocity of disk c with respect to b, that is disk with respect to the platform. Okay, this is the expression that we have. Now look here, first term that we have is angular acceleration of disk with respect to platform, angular acceleration of disk with respect to platform. We are given that the disk is rotating with respect to the platform at a constant angular velocity. It is saying it has a constant angular velocity. When the disk is having constant angular velocity with respect to the platform, therefore its angular acceleration, when disk is having constant angular velocity with respect to the platform, therefore its angular acceleration with respect to the platform will be 0. In the same way, it says that that the disk, that this platform is rotating with a constant rate. See, it is writing it's a constant rate of 1 radian per second. That is angular acceleration of platform with respect to the ground will also be 0, because its angular velocity with respect to the ground is constant. Okay, so this term is 0, this term is 0. So we are left with angular velocity of platform with respect to ground. Angular velocity of platform with respect to ground is minus k cap, that is minus k cap, and its cross product with angular velocity of disk with respect to the platform, angular velocity of the disk with respect to the platform, angular velocity of the disk. So here is a little correction here. This is angular acceleration of uh, angular velocity of platform with respect to the ground, that is minus k cap, cross product with angular acceleration of disk with respect to the ground. It will be here, sorry, this is with respect to the ground. Okay, so it will be 3j minus k cap. Okay, 3j minus k cap, angular velocity of platform with respect to ground, angular velocity of platform with respect to the ground is minus k cap, so it's minus k cap, cross product with angular velocity of disk with respect to the platform, angular velocity of the disk with respect to the platform is equal to 3j cap. So it is 3j cap. I will write here 3j cap. That is equal to 3, and minus 1 is minus 3, and we have k cross j. K cross j is minus I. Minus minus will become plus. Okay. Therefore, we will write. Therefore we can say that angular acceleration of disk with respect to the ground, angular acceleration of disk with respect to the ground is 3i radian, 3i radian per second square. Angular, the unit of angular acceleration is radian per second square. And look, when you talk about the disk, okay, the person on the ground will say that this disk is having angular acceleration, and its angular acceleration vector is along which axis? Along x-axis, along this axis, okay, along x-axis. So this is one thing of it. Okay, in order to find the velocity of A with respect to ground, we have to find the velocity of A with respect to the ground. Okay, so our frames of reference, both our moving frame of reference and the ground frame of reference, is having origin at O. This is given in the picture. So what we will say, velocity of A with respect to the ground is equal to velocity of O with respect to the ground plus angular velocity of A with respect to ground plus cross product with the radius vector drawn from O to A. That will be equal velocity of O with respect to ground. Look at point O. The point O is not moving with respect to the ground. Okay, this is not translating in any of the direction, neither x, neither y, neither z. Therefore, velocity of O with respect to ground will be 0. Now, angular velocity of disk with respect to the ground, we have just calculated. Angular velocity of disk with respect to the ground is 3j minus k cap. 3j minus k cap. And we have to take its cross product with ROA, the radius vector drawn from O to A. If you look at the radius vector from O to A, this radius vector is having, this radius vector is having a component along, it's having a component along y-axis, and it's having a component along z-axis. Its component along y-axis is equal to 1 j cap. So we'll write this as, this is cross product with j cap, and the component of A along z, it's equal to 0.25 along k cap. So it will be plus 0.25 k cap. This is the velocity. That is equal. Once you do it, so first of all, we have 3j cross j, that is equal to 0. So it is 3 into 0.25, that is equal to 0.75. So this is 0.75. And as far as j cross k is concerned, j cross k is I. So it is 0.55. Then we have k cross j. K cross j is minus I, minus minus will become plus. So it will be plus I cap. And then we have k cross k, that's equal to 0. Therefore, this will be equal to 0.75 plus 0.75 plus 1, that will be equal to 1.75 I cap. So this is 1.75 I cap meter per second is the velocity of A with respect to the ground. This is what it is. Velocity of A with respect to the ground, that is this point A will have a velocity. The observer on the ground will say that this point A is translating with a linear velocity of 1.75 meter per second along x-axis. Let's see what answer book has given. As far as the answer of the book is concerned, first the answer about the angular acceleration is fine. Okay, this is the correct answer we have derived. And what about the angular velocity? If you look at the angular velocities, here it is. The value of the angular velocity is 1.75 I cap meter per second. Okay, through the procedure I have discussed here. Okay, so our answer is correct. We are not bothered about the answer. Now let's go to the acceleration term. What we have to find is the angular, the acceleration. We have to calculate now the acceleration of the disk. Okay, acceleration of A. Sorry, not the angular acceleration, but the linear acceleration. We know in order to calculate acceleration of A with respect to ground, the expression for this is acceleration of A with respect to the ground is equal to, again, writing the previous acceleration terms we have derived, acceleration of, now we have to find acceleration of A with respect to ground. That will be equal to acceleration of A with respect to ground is equal to acceleration of O with respect to the ground, acceleration of O with respect to the ground plus angular acceleration of the cross product plus angular acceleration of the disk with respect to the ground, angular acceleration of disk with respect to the ground, angular acceleration of disk with respect to the ground, cross product with the radius vector drawn from O to A, ROA, plus angular velocity of disk with respect to the ground, and its cross product with angular velocity of the disk with respect to ground cross product with r OA vector. This is the expression that we already have derived to calculate the acceleration of A with respect to ground.